Assembly modeling. Hi, Joe Cerrone, CAD 230, Introduction to Solidworks. Today we're going to look at assembly modeling, and we're going to assemble this part here. If we look at the curriculum, if you want to get that from the book, you can go to the 2020 Basic Tools book, and it's Chapter 10, Bottom-Up Assembly. I've already downloaded the file. We can take a look at it right here. Tools needed. We're going to use mates. Mates you can kind of think of as glue, and mates allow us to glue these different pieces together. And what mates do is they allow certain movements or certain degrees of freedom. And so as we start to put things together, we can look at how the parts should move and apply these different mates so that they move within the boundaries of these different degrees of freedom. Essentially what we do when we mate them is we take away some of their freedom so that they can only move, say for this part, concentric about these spherical shapes. This will be an inch or an imperial assembly drawing. Tools needed, we'll use mates, move component, rotate component, place new component, interference origins, and concentric mates. Starting a new drawing, starting a new assembly. So what we'll do is we'll go ahead, start a new assembly, and then we'll browse for the parts. Now you should have the parts from the previous chapter. I'll take a look and double check on that. If there are any parts in this model that aren't, I will put them in the D2L course shell in the contents section for this. So we're going to start off by creating a new assembly, and then we're going to create or insert, let's see if we can make that a little bigger, this center ball joint. After we insert that, what we're going to do is we're going to display the origin. And what will happen is when we place the first component, it's fixed, meaning it doesn't move, and so there will be a letter F next to that component. So the first part that you put into the assembly is important, and the orientation of that part is also important. So let's get started. Here's what the assembly will look like. I just did a little bit of practice work on it. Depending on how you move these different components, depends on how you've constrained those different parts. I'm not going to save this, just going to bail out of it. And we're going to start a new one. New assembly, okay. Now it wants to know, it went right into the insert components area, and so it wants us to insert the first component, which will be this center ball. You can browse for it from when you previously did this. And then what it's saying is go ahead and show the origin. And so it would automatically go to the origin, but the origin is not displayed. And so what we can do is go to View, Hide Show, Origins, and this is where 0 is. And then when we click here, you'll see that the center of this part is now at the origin. And it's fixed. So if we look at the fixed part, we'll see that there's an F next to it. We're going to insert the second component, and this is what's known as a parent-child relationship. The first part that's inserted is the parent, and then all the remaining are their children. We'll bring in the ball joint assembly, and we could bring in more than one at a time, but the way the book goes through it has you bring one in and to mate it. And think of mates kind of as glue. And so we'll bring in this part, and then we'll hit the paper clip, and we'll select the inside face, and we'll select the face. And then Solidworks is pretty smart. It'll recommend a coincident mate because it knows there's two spherical, and those two mates would work together. And so as we start to mate these things, we can then move them around within the assembly, which is ideally how we make things nowadays. We can actually simulate everything on the screen. Switching back to Solidworks, we can say Insert Component. I can browse, or I can select my ball joint arm. say OK, and then I'll just bring this out here like that. We can mate this part to this component right here. It looks like it's at, I don't know, maybe 3 o'clock position there. So you hit the paper clip, select this face and this one here. It's mated, it's a little turned, so we might be able to kind of rotate it around a little bit. Because we haven't taken away all these degrees of freedom yet, because right now we can do whatever we want. We can go right through the part, we can move it. So the only degree of freedom that we have constrained so far is the concentric, meaning it can only move concentric to the other part. Now the textbook actually goes through and says to use under the assembly move part, move component. But it does it automatically. You don't have to actually go through and click on the move component to do what I did. So we can move it to this orientation using this standard drag. And then we'll insert another instance or another part, the same one, the ball joint arm solid part. And then we'll mate it here. And then we'll do that same technique 2 more times, here and here. Insert component. Drop it on the screen. You can hold the control key and click on an inserted component and drag off a secondary copy or a child. And then we can go to the paperclip here and we can mate this to this. It comes up with a concentric mate, which is fine. We'll green check mark that. And then we'll do it again. Here to here. Green check mark. We can go and we can move the component. And then we can add one more. Mate. And so as you can see, it defies normals by being able to walk through walls. Kind of has like a ghosting aspect of it, and it kind of twists and turns. And that's sort of the difficulty when you first start working with SolidWorks, is how to control these different motions. Sometimes the more you move it, the worse it gets. And so you want to be careful to move these components slowly in one piece at a time. Okay. So we'll add this T-joint and we'll mate that to these other 2 components, and we'll put 2 of those in, and then we'll save our work as our initials lab. I believe this is 9A, even though it's chapter 10. So back to, let's see, this is going to be lab 9A. Insert component. We're going to bring in the T-joint. And then we're going to mate that. And you want to think about it a little bit as you mate it. When I first did the practice on this, I was going to mate this one here to here, and then this one here to here, and it kind of turned it upside down. And so sometimes they can be a little bit more work. If you think about how you're going to mate the parts before you do it, what you can do is you can almost position these things how you expect them to be. And it makes your life a little bit easier. So we'll hit the paper clip, get this inside, get this spherical. It'll give us a concentric mate, and we'll green check mark it. Then we'll do it again. It stays in the mate command. It's modal. Insert that component, check mark it, and then you can do some basic motion. And like I said, slowly move it a little bit at a time, because it does have a tendency to go a little bit crazy on you otherwise. We'll insert the other one. And again, you know, as we look at these things, we can use these different components like rotate component, and we could rotate this component, sort of orientate it to the way you think it's going to want to be when it goes together. And same with these, you kind of want to kind of make them a little bit to that extent. Otherwise, it kind of tangles up a little bit. Mate. Green check mark. Change your orientation. Mate. Green check mark. Green check mark. Okay, save the file. Now the thing about Solidworks and when you create these assemblies is that it's a parametric program, and the reason that it's so popular in the manufacturing area is because it goes out and finds these parts. And so this assembly is made up of these three different parts. This part here, these parts here, and this part here. And so when we save the assembly model, the location of the components is important because it maps to where you saved those files. So the way that I keep my parts organized is I create a folder called Lab 9, or just 9 actually, and then I put all the components for that there. Now if you turn that in, or if you give that file to somebody else and that same directory structure is not there, then you will get an error because it won't be able to find the parts, because when somebody opens it on a different computer, the file structure isn't the same. So the way around that is to save the part as pack and go. So you can say File, Pack and Go, and so what Pack and Go will do is it will create a zip file. And so what we want to do is we want to create a zip file of all of these files, and it knows where they are already. And so we can go ahead and say, okay, that's fine, and we'll say save. And what I'm going to do is I'm going to browse to my location for this file, which I have a directory structure called 9, and I'm going to save it here. Apparently it just needs the folder. There we go. And then we'll hit save. And yes, 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 yes. And that will create a zip file that will be created within that folder. And then we can take that zip file and we can turn that into our D2L. I have an error in my video, so I'm going to correct it here. Rather than saving it to this folder, we're going to save it to a zip file. I did not check the correct box here. And so when I save it, I'm going to browse to my 9 folder and I'll hit save. And I'm going to name it my initials dash lab 9A. And this is going to be a zip file, and so I'll hit save, and then I'll hit save. And what that will do is to create a zipped file folder of all the components. And that's what you should turn into the Dropbox. So you should take that pack and go, click on it, right click, and then you can copy it and then paste it into the D2L assignments folder. The other thing that you might want to do is to create a PDF of the assembly. And we'll talk about that in the next video. Okay, this ends the video for Lab 9A.